All right, good afternoon, everybody. I'm Nick Farr, I'm the Herald Angel for this talk. One quick announcement before I get started. Please, if you can, leave feedback on all the different talks in the Pentabar system. If you actually go to events.ccc.de and click on the website link and click on the schedule link, there's a little green link right at the bottom of the information for each of the talks. Go there and leave feedback on all the talks you liked, all the talks you didn't like. Even if you were indifferent, leave feedback there. That's also a good place to leave feedback on talks that you really wanted to get into, but perhaps didn't. Also, if you have any other feedback regarding the streams or things like that, we also want to hear about that. This is a really great, the most popular Congress ever, and the organization staff is really interested in making sure that the 26C3 is an event that you'll really want to attend. But with no further ado, it's again my great pleasure to introduce a good friend of mine from NYC Resistor, Kelly Farrell. So please give her a huge round of applause.
Thank you all for coming out and for waking up this early. I know personally this is seriously the earliest I've been awake in 4 days. So I appreciate you guys coming out. My background is actually primarily in crafting. I got a degree in crafts. You can actually, they will issue you a university degree in arts and crafts. It's kind of amazing, and they gave me one. Specifically, I studied metalworking in college. I got interested in hacking when I met up with Bree Pettis, who started NYC Resistor, and he was like, hey, I just bought a knitting machine off eBay. Will you show me how to use it? And then I got interested in hardware hacking, and just kind of went from there. I'd had a little bit of a background from my parents, but since I was an angsty teenager, I didn't really want to do anything they were interested in. So my dad was like, let's build a robot, and I was like, no, I'm gonna knit. So that was that for a few years. So to kind of understand like why crafting is relevant to hacking at all, I know a lot of people have been like, so you're talking about crafts at a hacker conference, huh? And I think it's kind of important to understand the history of just computers in general. Specifically the weaving background. For anybody who's never, tried to weave something other than maybe like a kindergarten placemat, they're kind of like giant physical graphics processors, which, you probably didn't learn in elementary school. Just for some sort of background so that the next 10 minutes will make sense, there's two basic types of fiber when you weave. The warp, which is the long fibers, and then the weft, which goes across ways and goes over and under and over and under and over and under. I'm sure at some point you've had to like cut out construction paper and make a little weaving. And then on a loom, when you're doing a large project, it would be very tedious to actually have to sit over, under. So looms will do this for you, and they'll just separate everything out and decide for you. You can program which one you want to be on top and which one you want to be on bottom, the warp or the weft. And the space between the two is called a shed. It'll make a little more sense in a second. So there's a video here, and you can actually see the woman sits down, and there's a pedal on the floor that she presses, and it raises these harnesses. And the harness pulls various strings up to decide whether the warp or weft will be on top. She passes the yarn through, pulls a beater back to kind of pack it all down, and then, goes over and over and over. A loom can have anywhere from 2 to, as many as you want of harnesses. The most I've seen goes up to about 24 harnesses. And the harnesses control how many different patterns you can have. So most people have only done weaving over, under, but you could actually go over 1, under 2, over 2, under 1 to make different images. And the number of unique sheds you can have is determined by the number of harnesses. It's 2 to the power of the number of harnesses you have, minus 2, because if all of the strings are down or all the strings are up, you're not actually weaving, you're just passing it over an empty space. The thing is, if you have 254 possible patterns that you could do on any given row, if you think of a row is to a computer analog would be, if I'm weaving, it's like a row of pixels. And so every row could have any one of 254 pixel patterns. It gets really hard to manage really fast. And so in order to get around this, to not have to, have 254 foot pedals, they came up with what's called a Dobby loom. And a Dobby loom, they're pretty rad. It's sort of like a reusable punch card almost. They're these strips of wood with wooden pegs. And anywhere you put a wooden peg, it's going to lift up that harness. And anywhere there's not a wooden peg, it's going to leave those warp lengths down. So instead of having to remember first, I lift harness 1, then I lift harness 2, then I lift harness 8, then I lift harnesses 2 and 3 to get my pattern, you can just punch in the little pegs and then scroll through each one iteratively. The Dobby loom was awesome because it gave people the opportunity to really expand what they were doing without it being sort of incapable for a human to actually sit down and work with. Because having to remember all of these in order and then losing your place and going back is a huge pain in the ass. On the right, I've got an example textile that I wove. It's actually a double woven fabric. It's essentially 2 pieces of fabric that are woven at the same time on the same loom. And then everywhere you see a line between the 2 colors, so one of the fabrics is purple and one of the fabrics is yellow. And every time you see a change between the 2, it's actually swapping them as it's as it's weaving. So it's weaving 2, and then stopping, and then crossing the fibers, and then continuing to weave the 2 fabrics, and then crossing the fibers, and going on. And that's something that really wasn't easily done until they came out with easy ways to manage these huge number of harnesses. This is just a sample diagram of kind of what weaving patterns look like on a computer. So they're very slowly, the hobbyist looms are getting more computerized. It's a little bit sad kind of how slowly it's happening. About 4 years ago, I was working on a Dobby loom, which was computer controlled, but it's saved to 3¼ inch floppy disks. And they were really, really, really excited because their biggest loom, this is a huge loom, by the way. This is like a $300,000 jacquard, takes up an entire room. They had to build new foundation to support it. They're like, it's getting an Ethernet port. I was like, okay, welcome to 10 years ago. But so the technology for this is fascinating because the loom has given so much to technology, and then just kind of went off in its own little sad direction. And the Dobby mechanisms that are computerized, they're very simple. It just takes a black and white pattern and just plugs it in and raises and lowers levers. And I was looking at these things, and they're like, Compu Dobby 2 system runs on, with Palm Pilot 3 input, $4,000. I was just like, But this is a kind of a basic, the threading is up at the top, and the threading on a loom is actually, it's kind of like your operating system on a computer. You thread it depending on what you want to do, and then you can actually input the same pattern of raising the harnesses into a different, depending on how the machine is threaded, it will look totally different. So you can send it the same commands, essentially, but it's not going to look the same if it's threaded differently. So some of the things that have come out of this is network twills, which is sort of a hack to get more gradients and smooth lines out of weaving, because just like in computer graphics, your basic element is a rectangle, and so if you want to get like a circle, your options are to either go really high res, which in weaving means getting really, really tiny yarn, and that's really tedious. Or you can kind of do these different things to emulate the idea of curves and shading. So network twills is something that people kind of got into in the 80s, where you thread the machine in such a way that you can put in a curve and it will do the dithering on its own, and you don't have to sit there and program that in. And then this is just an example of a network twill diagram. They're substantially more complicated. I actually don't quite get network twills because they're really weird, but they look pretty rad. So jacquard looms, unlike a table loom, they don't have any harnesses, meaning that every single warp thread is controlled individually, which makes them a total pain to set up. Jacquard looms are actually pretty much only used industrially and then maybe in like an educational setting. Most people do not have a jacquard loom in their home. The Dobby looms actually post-date the jacquard loom. The jacquard loom is a little bit earlier. But for the hobbyist and the kind of artistic uses, the Dobbies are much more popular because even though they're slightly more limited in what they can do, because you can set up a Dobby loom start to finish in probably half a day, you know, starting from having the yarn in a big ball and winding it out and dressing the loom. And the jacquard loom, there was one that they had at the Rhode Island School of Design, and it had 2,000 ends, which is actually not that big of a bed. It's probably about this wide. It took 2 women 3 days to string it initially, and then they string it once and they never string it again. They had this giant spool of thread, and what they actually do is when they get close to the end of the thread, they have a robot, and the robot comes up to it and cuts every thread and ties a new one on a new giant spool, and they just continually tie in the new warps because threading the machine is such a pain. They're monstrous machines. At the Rhode Island School of Design, they had to reinforce the foundation to support the weight of it. They had to build catwalks to access the top of it. They're not really a fun home project, but they are awesome machines. And this is how a lot of modern textiles are made. I was actually touring a weaving factory, or a textile mill, and they said, well, when we need to get faster, if we need to ramp up our production, it doesn't make sense for us to build a new building, hire new staff, do all this stuff, pay extra utilities. Instead, what we do is we look at the slowest machines and say, the machines actually, they automatically do everything. When you watch them, the fabric looks like it's growing out of them. And they said, well, we look at the slow ones, the ones that only, run the yarn across 6 times a second. When we buy a faster one, that goes like 30 times a second. So instead of expanding our inventory of machines, we just get faster and faster and faster. So there were a lot of other people that contributed to the kind of development of the punch card. Jacquard was the person who sort of sat down and collected it all and put it together. He gets all the credit, sort of like Christopher Columbus gets most of the credit for discovering America, but whatever. So you can see that it's a lot like computer punch cards, and it just determines whether or not, which thread will be on top or bottom. All right. So there's some artists who are doing some really awesome stuff with this technology. And by technology, I mean, like 200-year-old technology. Christy Matson is one of them. What she does is she takes sound files and then maps the frequency to either high or low pitches, and then weaves those resulting images, the up and down, black or white, in copper. And then after she's woven them in copper, she actually hooks it up to what is a giant theremin so that people can interact with it. Let's see if my sound is working. So if you're familiar with how a theremin works, your presence around the antenna, which in this case is the giant weaving, changes the pitch by changing the electromagnetic fields around it. So these are these giant interactive sculptures that she's created on a loom, and they're actually multi-interactive. When multiple people touch multiple ones, they make different sounds. Yeah, so what she does is she analyzes the frequencies in the sound files, and sort of picks different breaks in the frequency levels, and then if it's and maps those to the grid that she's putting into the loom. Because you program these looms, you get this grid of black and white, and black means that the harness is raised, white means the harness is down, and that controls which whether the lengthwise or crosswise thread is on top. And so she kind of decides which frequency she's looking for, and then maps whether or not they're there at various points in the song. This is a project that's just a little bit silly, but I thought it was fun. This guy has taken needlepoint and created a needlepoint Apple II. It's not actually an electronic project, but it's got these removable cards for Google and a couple other things like the Windows wait timer that slip in the top. The News Knitter is a really interesting project. It uses an industrial knitting machine, and it takes headlines from the AP Newswire and just spits them out in cloth. It's actually written using processing. It's one of processing's kind of exciting, heralded, look at us, we're processing sort of projects. But I think it's really fascinating, and they're actually even selling some of the garments made from it. Knitting machines in general, by the way, are a lot of fun. They're sort of waiting to be hacked. They're this neglected technology. People lost interest in them in the 80s. And the machine that both Bree and I have, which is a KH930, has an I/O port on the back, which at one point interfaced with a 5-inch floppy, and now interfaces with nothing, and the cables are very simple and very expensive, so it's kind of waiting for someone to tackle that and figure out what those pins do. So the kind of state of the crafting community. Crafting community is a lot like the hacker community, but flipped. There's not a lot of girls at this conference. As I'm sure some of you noticed, the lines for the men's room are very long, lines for the women's room are very short. Craft shows are the opposite. My boyfriend loves going to craft shows because the line for the men's room is non-existent. It's very much, like the genders are flipped, but otherwise it's very similar. Why are you crafting? Well, because I want to I just want to make something, like, whatever. The idea of wanting to understand how something was made, to make it with your own hands, get a better appreciation for it. Sometimes it's just because what you want is not available. I'm sure you guys have experienced that with software or hardware. Nobody's making what you want. Same thing happens in crafts. Sometimes you just don't want to pay what someone else wants you to pay for it, and you can do it better a lot more easily. Or it's just something to do. I think all of us sort of have a need to do something that's not play video games all the time, although that's totally acceptable. And they share a lot of common needs, especially for people who live in large cities, small apartments. It can be really hard to find a place to work. It can be really hard to find a place to put giant tools. Not a lot of people have room for a drill press in their apartment. If you do, that's fantastic. I'll move in with you. But the need for community. It can be really isolating to work on some of these projects that are not necessarily a group project. Knitting is not exactly a multi-person activity. But it is nice to have other people around, much like when you're coding or working on a circuit and you're beating your head against the wall, why is this not working? And your friend walks over and flips a switch, and then you're on your way again. The same thing happens in crafts. So I'm just going to flip through what I consider material hacking. These are projects that are not electronic in nature, but are where people have taken an existing technique or material and done something different with it. Something kind of beyond its original purpose. The first is it's a necklace. It's made out of an inner tube, and she actually cuts them by hand, taking like a bicycle tube and forming them. The next one is a bracelet. The little colored paper there, the colored bits in the middle is actually folded magazine pages in between metal. The lamp on the bottom, I think it's made out of I'm not sure if it's a crock pot or a rice cooker, but it's been repurposed as a lamp. The rose is made out of coffee filters, and the bracelet there is actually, that's fabric that's been folded and sewn so much that it actually has a very dimensional and stable quality, and you can squish it and it pops right back up. They're kind of incredible. Machine embroidering is another hack, and by machine embroidery, I don't mean the big machines where you punch in a design and you download, precious moments, children smiling, number 53, and it puts it on a shirt. This is actually freehand machine embroidery. It's a technique that's been adapted from sock darning. So darning is something no one does anymore, but if you get a hole in your jeans, you put it on the machine, run it all around, covers it in stitches, hole is patched. It's been adapted for creating dimensional images. So this image here is actually done entirely on the freehand knitting machine. So she just took a big loop and it's sort of hard to explain, but the fiber goes everywhere. And they're a lot of fun to watch. Cake hacking is another fun one. My friend Alicia did these. The first one is just a light up LED cake. Kind of makes the candles hard to blow out, but still fun. The second one is a servo motor cake for a friend of ours who does a lot of work with servos, and the birthday candles actually spin around. And then the last one Alicia did for her boyfriend Dino, who's a fairly well-known security guy. She iced the message "Happy Birthday," which was encoded with his public PGP key. And now you all know how old he is. So open source crafting is a but comparatively new thing. It's similar to open source software in a lot of ways. It's the idea that these techniques, which sometimes have been very well guarded, sometimes for centuries, are coming out in the open. And that if you're running a business, what you're selling is not, oh, well, I'm the only person who knows how to make a vase. It's just that my vases are so much better than yours, I can tell you how to do it, I don't care. And there's a couple different communities that are really fostering that environment. The first is Craftster, it's actually just a discussion board. It sort of grew amorphously of its own thing. It was one of the first ones out there when there weren't really a lot of resources for crafters online, and people who were stuck at home or otherwise looking for a sense of community came to the site, and they'll post total instructions. They'll post a project they did and instructions on how they did them. This one is a lamp made out of Legos. A couple other sites include Ravelry, which I'm not sure how many of you attended Bree's talk on rapid prototyping, but there's a site called Thingiverse where you can upload digital files of things you've done, and other people download and make them themselves. Ravelry is like that, but for knitting and crocheting. So I can upload a pattern for knitting, and someone else can download it and then make one, and then post a photo of the thing they've done. So it's this awesome repository and community of just fiber patterns. So if I want to make a hat, I type in hat, and suddenly I see all of these images of all of these hats that I can download and make. The other awesome thing about the shared mentality between crafting and hacking is that it's a really easy way of getting people interested in the technology side of things. One of our most popular events at NYC Resistor is Craft and Hack Night. It's actually mostly women, and we're very proud of the fact that we can say that our most popular public event at our hackerspace is mostly chicks. And it's awesome because it's been kind of astounding the number of people who came in and said, oh, I'm just going to knit in the corner. And then the next week said, oh, well, can I put some LEDs on that? And then, oh, well, how does a servo motor work? And admittedly, that's kind of how I got into it. As I said, yeah, I'll show you how to use a knitting machine, and hey, what are you doing with that Arduino? So these are just a couple simple projects, varying levels of simplicity. The one on the left is a ceramic alien sort of thing with light up eyes, simple LED project. The one on the right is actually a dress, and it's covered in electroluminescent wire. And as the wearer walks, there's an accelerometer that changes the brightness of the flames on the dress. It's a little bit hard to see in that picture, but it's a lot of really fun stuff. So another way that people are really starting to get into this is the wide availability of kits. Kits have become insanely popular. And actually the popularity of kits has actually been, I think, helped by the recession, at least in the US. The New York Times was reporting that companies that sell crafting supplies, like craft supply stores, have actually had a better holiday season in past years. And I think part of it is that people see a lot of value in, the sort of do-it-yourself mojo when there's not a lot of cash to spend. So these are just some basic kits that I found on the internet that I think are kind of good gateway projects for people who are getting interested in hacking. The first one is a Twitchy kit. It's actually made by my friend Raf. And what they are is a servo kit, and you make a nice soft case for it. Like in this case, it's a scorpion. I've seen one that was like a little green monster. I also saw one that was half of a baby doll. And if you really want to disturb someone, hand them half of a twitching baby doll. Gets them every time. So, and the next one is just Blinky Bug. It's a super simple project that introduces people to basic concepts like this is what happens when you attach an LED to a battery. And the LED menorah is a really fun one. It's a microcontroller that you solder the LEDs to, and every time you turn it on, one more lights up. And then the flowers, just again, really simple LED project. LEDs are really popular for intro crafting projects. They look cool, they're easy, they're cheap, and it's really hard to hurt yourself with them. Which, as someone who got her fair share of burns in metalsmithing school, it's a good thing. So two of the best things I think that the hacker, or in general, that can kind of bring hacking to more crafty or otherwise uninitiated people are Arduino and processing. I know a lot of people get really snobby about Arduino and processing. I hear a lot of, processing's not a real language. Arduino is so much lamer than this other. Get over it. I think that the rampant, it's not helpful. I think that, yes, they're limited. Yeah, it's programming on training wheels and microcontrollers on training wheels. But not everyone has access to the same background that everyone else did. Not everyone has the patience to sit down and figure out how to use the GCC compiler. If you do, and that's fantastic, but I think everyone starts at different places. And I know for me, the idea of sitting down with a microcontroller, I had some like TI kit, AVR programmer, and I was like, I don't get this, I'm out. And then a couple years later, I sat down with an Arduino, and I was like, oh, this makes sense. So this is a project I did in processing. I don't know if any of you guys saw Bree's discussion on rapid prototyping where he drew a little design in CAD. I personally hate CAD programs. I'm not willing to learn how to use them. I'm not willing to learn how to use them so much that I was willing to learn processing to draw the files for me. These are origami boxes. I make these tiny dinosaurs, and I needed a box for them. And I didn't want to have to draw it over and over to get the sizes I wanted. So I actually wrote a program in processing to generate it for me. If anyone is too snobby to use processing or just doesn't like it, there's also a very similar library in Python, which I've started documenting. I found it on the web. There really wasn't a lot of documentation for it. I threw some up on my blog. If anybody else, can do a better job, you're welcome to. But I was learning Python as I went along. Sorry, I'm supposed to turn the sound off so you wouldn't hear the bad music we listen to at NYCR sometimes. So this is actually one of the earlier hardware projects that I did with just light and using processing to generate objects. So again, I didn't really want to have to redraw these cubes I was making for this lamp. So instead, I decided that I would much rather, see if I can bring this over here, generate them automatically. This is the actual processing sketch that I used where you can input the box size, thickness, and height. See if it'll run for me. Maybe not. Oh, there it is. It's over here. So it just automatically spits out the pattern, so I don't have to redraw it every time I decide I want a different size cube. Where did we go? And then these are just some extra projects I thought might be interesting. The first on the top left, it's actually a working microphone embedded in a ring. It's got a little port on the side. The second is a microphone that's been repurposed as a lamp. And then the last one, this is awesome artist. They go by Rare Beasts on the site Etsy, and they make all of these very strange sound objects. They make tiny miniature synthesizers. They have a synth that's about that big. And this one is just kind of a weird sound generating box, and so those are a lot of fun. So the projects that I've kind of gone through, this is really just the very start of the wealth of projects that are out there. And there's so much more that there's so much more to it that it's way too much to kind of cram into one little talk. You know, I could go on about weaving for probably another hour and a half, but everyone's eyes would glaze over. And I think that introducing people to hardware hacking is a lot easier if you have something more innocuous like crafting. You know, I think especially when you're talking about people who aren't familiar with the term hacking at all, putting a nice plush smile on it makes it a little more approachable. And you know, like I said earlier, the hacking community is really male-centric for about 1,000 reasons, which I will spare you all a discussion on. But it's, you know, it's a fact of the matter, and it would be great if there was a more even distribution at these events, if for no other reason than the bathroom minds might be more even. And I think that really embracing the craft side of things is a great way of approaching that. And lastly, I think that one of the most common excuses for why people have not got a hackerspace in their area is, oh, well, there's not enough people interested. You know, I'm lucky I live in New York. There's tons of people interested, but people who are living in more rural areas or, you know, more spread out areas are saying, oh, well, there's just not enough people in my area who are interested in doing that. I think that if you reach out to the crafter community, which exists in most areas, you'll find that a lot of the needs are the same in terms of a group and a space. And if there aren't enough people for a hacker space in your area, you can think about doing just a maker space, because there's crafter spaces, there's hacker spaces, they need the same stuff. You can very easily sort of combine that and just say, this is a space where people make things. You can make stuffed animals, you can make microcontrollers, but you know, it's pooling your resources. So I've talked much faster than I originally intended to. So we have a little bit of time for questions. If anybody has any, I'm welcome to answer them. If anybody wants me to go in more in depth about anything I've talked about, I just kind of glossed over a lot of it, but anyone?
The processing sketch or the result of it, how did you print this?
So I have access to a 35-watt laser cutter, which is one of the benefits of pooling resources. It's definitely not something that I would have on my own. At NYC Resistor, we actually got together and a whole bunch of us threw in on a laser cutter, which we're still paying off. But it's a fantastic resource to have. You can also, there are outside companies like Pinocchio and a couple others which will cut stuff for you if you don't have the tools in-house. But the reason that I did this in processing and then Python particularly is that they have options to export scalable vectors, which is what the laser needs to cut, as opposed to a raster image. Nick?
Hi, Kelly. I have a question. What's the proper procedure immediately before commencing a laser cut at NYC Resistor? What's the final thing before actually pressing the button?
Well, there's a checklist. The first thing you have to do is make sure you've turned on the filter so we won't all die of noxious gases. The second is to make sure you've turned on the air compressor so it won't catch on fire. The third is to make sure it's in focus because you want to actually cut through the piece. And then the last and most important step is to yell. I think Zach is here. Would you like to yell it for us? Fire the laser! For anybody who did not hear that, it's fire the laser. So any other questions? Anyone? Okay. Thank you very much.